Good morning, or good evening, or good afternoon, whatever time you all will be watching this. I am recording this as a reflection for my Physics 281 lab, and I want to preface by discussing or mentioning part of the reading that we were assigned, physics or science and its way of knowing. Very, very interesting selection, but one of the more important things that I saw in the video was that, or in the reading, was that each scientist has their own way of addressing and approaching and thinking about science. There are scientists that have a far more bold and courageous interpretation when they do experiments or labs, and then there's those that stick to more reliable and very direct approaches. Um, Additionally, there is also a level of individuality that came with the reading. The idea that each scientist, whether that be a physicist or a chemist or a biologist, they all of which have their own personal and individual aspects to their approach. They all have their own biases, they all have their own limitations, they all have their own creative ways of approaching what they wish to study. So, to address the prompts, when it comes to what is physics, I have some notes. The way in which I wanted to approach this question was similar to how the reading approaches what is science, and how it is less so uh, just like a rigid thing, to be studied and understood. Rather, it is something to be thought about. It's something to be explored. So, physics as a whole, I would say, is a way of thinking, a way of approaching the physical world, the outer world, a way of thinking about how, given a problem, given a thought, how somebody can use the tools of math and theory and approach this problem or approach this thought and see how far they can get to understanding it. And that last bit, seeing how far they can get to understanding it, is the preface here, is that they, as scientists and as a discipline, it is something, physics is something to be understood, something to be explored, something that is continuously being explored. And this kind of segues into what is the goal of physics, and that is to, in my personal opinion, to push the needle in our understanding of the world and what is around us, what is above us, what is beneath us, what is inside of us, what is seen, what is unseen. And I, as an aspiring and becoming physicist, still in the process, but me and my own, uniqueness, or to me, is that, as a scientist, it is one thing to explore and to see the theories and what have you, but I also am quite religious, and as a Muslim, it is also a factor that plays into how I think and how I behave and how I live my life. And it applies to this just as much as it applies to anything else in my life. And when it comes to approaching science, and when it comes to the goal of physics, I wanted to see if I can draw parallels and see if I can kind of have a middle ground between the two. Because oftentimes, even in the selection, uh, religion and science is put against each other or divided. However, for me, in my own interpretation, I see it more as science as a way of being a means to understanding my creator's creation. And there are the things that are unseen, the things that are unknown, just like how science sees it. And we believe in those things, just as how science sees it. And further to this point, I don't believe that the goal of physics is to uncover everything and have one singular textbook that is from A to Z everything in the universe. I believe it's more along the lines of seeing where we can question, where we can learn, where we can observe, and should we not be able to observe, where we can think. And that also tying in one of my own interests, which is quantum physics and quantum computing and things of that nature. There is no way to see qubits, there is no way to see atoms and this and that and the other, but we can study their effects, and they have been studied. And I like to kind of think of it as, it's like if you have this model that is classical, that is, think of a classical computer. Quantum computing and quantum physics, that approaches from a completely different perspective. It challenges it. And that is another kind of key point to physics, and what its goal is to create this set of rules to understanding the universe, but also to create a playing field of challenging and understanding and developing with other scientists and other physicists. And to that point, a physicist is somebody that can think, somebody that can imagine, and somebody that can essentially combine their own interpretations, their own imaginations, with key principles, mathematics and the theory that goes on with that, and combining those two things to present something that is going to push the needle in physics. And when it comes to being a good physicist, I believe that, and this is where I wanted to tie both being a Muslim and being a good physicist to me, is first off having a good intention when it comes to genuinely wanting to understand something and to further the knowledge of other people, but also having the humility to say that the more that I study, the more that I learn, the more that I progress, the less I know. Because oftentimes the more, especially in science, when the more you learn, the more you go on with your classes, the more you go on with, learning and learning and learning, you come to truly realize how ignorant you are, in a sense. How little you know compared to what is truly out there. As a matter of fact, I saw this video just this past break, and it was a professor introducing quantum mechanics. And he said that he had good news and bad news for his students. The first being, the good news, is that, well, no, he actually started with the bad news. He said the bad news is that quantum mechanics is a intuitively impossible thing. He said that it is incredibly difficult to understand, so much so that most people don't understand it, if not anybody truly understands it. However, the good news is that, nobody understands it. And in that sense, he followed and said that he was the only one that truly doesn't understand quantum mechanics. Within a week or 2 weeks, all of you will be able to share in his ignorance of not understanding. And that kind of goes along with the fact that, the more that you learn, to have the humility to say that I don't know is something very important to being a good physicist. A good physicist is never a know-it-all. Rather, a good physicist will say, I don't know, but I'll see if I can find out. And the last of which, to being a good physicist, is to have trust in your work. If you've seen, if you've observed it, if you've tested it, if you've gone through the measures of the scientific process, which is inherently a collaborative effort, being able to trust in what you found so that you can move forward. Because if you get hung up on one particular topic and not knowing whether you got it right or not, even if everybody's telling you, well, no, we agree, and the science agrees and the data agrees, but then you're stuck on it, you'll never get anywhere. But the last kind of key point to this video is that overall, from the readings, from my own experience, I think the most fundamental aspect to being a good physicist, to being a physicist in general, to understanding science, and to moving the needle and actually getting to the goal of physics, is to have an innate curiosity and be able to think and chase. And that is all I have for you all. Good morning, good evening, and good night.